We ran out of time before we finished the debriefing of application exercise 1-4. The nice thing about this problem, well, in my opinion, maybe not yours, it requires you to know all the skills that are presented in Chapter 2. I have the handout in front of me, and hopefully you have the handout in front of you too. If you did not get one in class, I put a PDF file of the handout up on the Moodle page. Make sure to print that out or have that open on another screen as you view this. Anyway, here's the problem that I asked you to do. And we did discuss the answer to this one somewhat, but we didn't discuss the pieces of this problem in the way that I wanted to. So here we go. The way these problems always start is to give you productivity information. And sometimes that productivity information is given in terms of output per unit of time. So here we see for VV, 1 pizza per hour, 3 orders of wings. Notice that these are the outputs divided by the inputs. And that, if you can produce more in the same given time, you're more productive. If you can produce less units in a given time, you're less productive. So that's fine. I do want to emphasize that whether you're given the information in the productivity information in terms of output per hour or hours per unit of output, it's the same information. That's why in this problem, Colin, I think, is the student that noticed it first, but some of you had the productivity information in one form and others of you had it in another form. Notice that this is the same information. The table on the left gives you the same information as the table on the right. If one can make 3 orders of wings, as VV can in an hour, well, that means it takes a third of an hour, otherwise known as 20 minutes, to make 1 order of wings. This entity, 1/3 of an hour per order of wings, is just the reciprocal of this entity. And it's the same exact information, the same exact calculation of opportunity costs, etc. Just think it through and proceed with the information you have. If you prefer productivity information in this form of output per hour and you're given it in terms of hours per unit of output, we'll just take all the reciprocals and you're back to where you like it. And I'm gonna, there's a 50% chance I give it to you in one way or the other way. It shouldn't make any difference to you, so make sure you practice that. The other key skill embedded in this problem, I asked you about, which answers A and B require you to, is it A and B? Yeah, to know in which sector the person has the comparative advantage, and that requires calculating the opportunity costs. And there's many ways to calculate opportunity costs. Let me. I actually have gone over that in one of the wrap-up screencasts, so I won't beat that to death. But suffice it to say, you have to convert the information on productivity to opportunity costs. There's an easier way to do that I'm going to tell you when I get to the graphs of this problem. That's probably the easiest way. But the way I talk through in the screencast, where you think about VV moving her time out of pizza and into wings, how much pizza does she give up? How many wings does she get? That way works great and it's intuitive. Taking the ratio of either the unit labor coefficient of each good, one unit labor coefficient to the other unit labor coefficient, that's how much time per unit of output. That'll work, but you have to keep your units straight. Same thing, whichever productivity information you use, you can just take the ratio of the person's productivity in pizza and the productivity in wings and do the unit check to make sure you got it right, what you give up over what you get. Again, there's a screencast on that, but make sure you're solid on that skill as we go into this exam 1 in a couple weeks. Anyway, so when we compare opportunity costs, we see that the comparative advantage, a person has a comparative advantage in a sector if their opportunity costs are lower. So when we look at pizza, we see that David's opportunity cost of pizza, one order of wings per pizza, is much lower than Vivi's opportunity costs. Likewise, when we go to wings, Vivi's 1/3 of a pizza per order of wings is much lower than David's opportunity cost of one pizza per order of wings. So David has the comparative advantage in pizza, Vivi in wings, and actually that should have ruled out answer B. A couple of people answered B, but A was the better guess, or the better attempt, that and that David did have a comparative advantage in pizza, and that's more valuable. How do we know it's more valuable? Well, we're given the price information that you need to give up 2 wings to get one pizza, 2 orders of wings to get 1 pizza. Let's go on. I wanted to walk you through the graphs that go with this. So I asked for the graphs in part because it's how we would answer the question of who gains more from trade. To get this graph right, to do this graph well, you need to start with the production possibility curves of each one. And notice that I asked for the production possibility curve for a day's worth of production. So the way you get this is the given information is that Vivi works 10 hours and she can make 3 orders of wings per day. Per hour. So if she spent all her time making wings, she could make 30 of them. So that's one endpoint. And then if she makes 1 pizza per hour, and in that case she could make 10 pizzas. Nobody has an absolute advantage in pizza. They each can make 10 pizzas per hour. Absolute advantage just compares productivities. But remember that the gains from trade, specialization in trade, is based on comparative advantage. So be ready for a problem where, and you'll get these on your homework, similar problems to these, but where one party has an absolute disadvantage in both sectors, but nevertheless there's gains from trade to be had. Anyway, you with these constant trade-off, anytime she can make 1 pizza per hour, whether she's making 10 pizzas or 0 pizzas, then you have in 3 orders of wing per hour, you have a constant trade-off. And these PPCs are just straight lines. You just find the endpoints, connect the dots. The gains from trade, you figure out whether she specializes in wings or in pizza by comparing the opportunity costs. But then to get the trade possibility, once you've deduced that Vivi is going to have a comparative advantage in wings, and we know specialization in the area of comparative advantage is the way to maximize well-being for the system, then you got to figure out the trade possibility curve. And the trade possibility curve always is a line with the slope of the trading prices, which, by the way, are always the price of the good on the x-axis divided by the price of the good on the y-axis. The price of a pizza was $20 per pizza, $20 per pizza. And the price of wings was $10 per order of wings. And notice that relative price is equal to 2, and we better check the units. So the dollar in the numerator cancels with the dollar in the denominator, and then if we multiply both the numerator and the denominator by orders of wings, the denominator goes to 1, and we have wings over pizza. And we know that we're in a space where on the y-axis we have orders of wings, and on the x-axis we have order of, pizza pies. So wing per pizza pie is the slope of this trade line. If you got it backwards, you would have wings over pizza, and that makes no sense. The slope is rise over run, not run over rise. We have pizza on the x-axis and wings on the y-axis. So practice that. And then the gains from trade, one way to think about the gains of trade is just how much the trade possibility curve has moved away from the production possibility curve. Notice that the shaded blue area, I'm shading it now, that's all, with specialization in trade, all that shaded blue area are points that would have been impossible if the person were not trading, producing and consuming everything for themselves. The shaded blue area is the expansion of the possible consumption set through specialization in trade. So the size of that area is one proxy for gains of trade. And notice by that logic, I'm going to change my... By that logic, if through trade one faced trading prices that are very similar to one's own opportunity costs, the gains from trade are pretty small. And that would make, and on the other hand, if the trading prices are really different from your opportunity costs, the gains are really big. And that logic would support answer D. And answer D was a good answer. Answer C was somewhat better, but answer C required you to know stuff that you're going to learn in later courses. So answer D was probably the best answer given what you had. Although you could probably deduce that, geez, these production possibility curves and trade possibility curves tells us the possibilities, but it doesn't tell what people would actually choose. We need information or a way to build people's preferences into our model. And that's what we do in later courses. Economics 327 is the next course after this one, and we spend a lot of time doing that. Is there any other skill that I wanted to make sure you had? Well, the other thing going on, if they split their time equally, you want to be able to identify that they're at the midpoint of the line. If they were 3/4 of their time in pizza and 1/4 of their time in wings, they'd be down here, etc. So be ready to do that. All right, that's a long screencast. I think that's enough.